Hello everyone. Hi guys. Okay, we're gonna be doing laws of exponents. So law number 1 says, in words, when adding powers of the same base, we add the exponents. If we have something like this, as long as there's a multiplication in between, what will be the answer? M plus n. So an example for that, if you are given x2 multiplied by x3, the answer will be x5. And then, or if you are given x dot x4, if there's nothing here, there's an invisible 1. And then a dot means what? Multiply. So 1 plus 4 will be x5 also. So whenever we are multiplying the exponents, we add the multiplying the bases, we add the exponents. Law number 2 says, when dividing powers of the same base, we subtract the exponents. So this would be m minus n. Always the top one minus the bottom one, even if the top one is smaller than the bottom one. So example will be, if you are given y6 over y4, you must always show your workings on your test. Are we all clear? Yes, sir. So 6 minus 4, you need to show it, guys. 6 minus 4 is how much? 2. So that makes sense. You get 2 marks for your method and a mark for your step. Another example will be if I'm given x3 over x7. So what am I going to do? 3 minus 7, which will be negative 4. So mark for the method, mark for the answer, x minus 4. But if we have a negative, we need to take it a step further and say, write it as a positive exponent, meaning we have 4 x's at the bottom. Now, okay, let me explain this one. If I were to expand this, x, I have 3 x's on top. And how many x's at the bottom? 1, 2, 3, 4, 5, 6, 7. So if I were to expand this, I have 3 x's on top and 7 x's at the bottom. So if they cancel each other out, I'll be left with 1, 2, 3, 1, 2, 3, 4. I'll be left with 4 x's at the numerator. So that's why if you are to write it as a positive exponent, you must write it as a numerator. So whenever you see a negative exponent there, it tells you that that has to be a denominator, a fraction. So we've got 4 x's at the numerator. That's why we write it like this. If all the time, but if they say leave your answer as a positive exponent, this is what you do. If you have a question like this and they say write it as a positive exponent, what is it going to be? 1 over y squared. Good, fine. That's law 1 and law 2. Law number 3. Law number 3 says, if you have a power raised to a power, you multiply the exponents. So obviously from primary we know that bracket means what? Times. So whenever you see a bracket, it means you're going to multiply the exponents. So example will be what? Let's say we have x3, 2. You must show the workings. So 3 multiplied by 2. You get a mark for this, for showing the step, right? Yes, sir. And then your answer will be how much? 6. Don't go from here to here. You lose 1 mark. If you are given 4 and 5, it's what? 4 multiplied by 5. It's 20. Is it fine? And then that's it. Whenever we see a bracket, we multiply. And then law number 5 law number 4, ne? Law number 4 says if we have a product raised to a power there, we are gonna multiply the exponent for each. We're gonna distribute the exponents such that we have am and b exponent m. Is that fine? So everything inside the bracket is affected by what? By m. Is that fine? So meaning x squared y cubed squared will be how much? Will be multiply 3 multiplied, which is x to the power 4 and y to the power 6. Is that fine? And 2x3y squared will be how much? Everything. So here, if there's nothing, there's an invincible 1. So we're going to distribute that. It's going to be 2 squared x6 y2, which simplifies to x to the power 6 and y to the power 2. The 2 squared, we need to simplify it and get the value for that, which is 4. Is that fine? Yes. And then, what happens if we have a negative inside the bracket? Now, let me give you something like this. And then if we have something like this. Now, quickly I'm going to write this down. If we have a negative inside the bracket and the exponent here is an even number, the answer will always be a positive. So it's easy to do that. And then if you have a positive number, a negative number, and then you have an odd exponent, the answer will always be a negative. And then if it's a positive, even or odd, the answer is always a positive. So we don't worry with that one. We only worry when we have a negative inside the bracket. Is that clear? Even number, positive, and then odd number, a negative. So for this one, already we know the sign for this answer. Because of this is an odd number. The answer is going to be a negative. And then we multiply. 2 multiplied by 3, our answer is 6. And then here it's a what? The answer is going to be a positive because of an even number. And then we multiply. Bracket means multiply. So 3 multiplied by 2, the answer is what? 6. So once you know this, for a test, it becomes easy to solve. Because the rest you just distribute in. Are we all clear? Okay. Okay, then we've got a property. Other textbooks call it law 5, but it's actually a property that says anything raised to an exponent of 0 is 1. So how do we get this? Let's say you're given x over x. We know there's invincible 1 here, which is 1 minus 1, which will be 0. So this becomes how much? 1. Or you can say, how many times does x go into x? Once. So that's why we have a relationship between that. So anything raised to 0 is 1. How many times does p go into p? How many times? ones. So that's why the answer will always be 1. Okay, now let's do some questions. So based on all the laws we have done, let's try to do some basic questions. This would be when multiplying powers of the same base, 2 plus 3, this will be 5. Show your method, show your working. So I'll just write for now law number 1. For practice, you know, law number 1 says add the exponents. You don't have to write this, but for you, for your reference. And then here, if there's no exponent here, there's an invincible 1. And then 9 plus 1 is how much? 10. Which law did we use? Law number 1. Is that fine, guys? And then here, when it comes to the numbers, what is the sign in between? Multiply. So I'm going to multiply 3 and 4, which is how much? 12. And then when it comes to the variables, I'm going to apply law number 1, which says add the exponents. 2 plus 3 is how much? How much is 2 plus 3? 5. So you get a mark for 12, you get a mark for the method, you get a mark for the final answer. So don't forget that. And then here, we did law number 2. Law number 2 says when dividing powers of the same base, we subtract the exponents. So what will be the answer? 13 minus 11 will be how much? 2. What law is this? Law number 2 says subtract the exponents. So a mark for method, a mark for an answer. Don't forget to show your method. Okay, moving along. Here, we're going to do the same thing. We're going to subtract. So you write one base and then you say 18 minus 8, which will be how much? 10. A mark for the method, a mark for the answer. Okay. Moving along. Let's solve this ones. So here, you're going to look at the ones that has the same base, and then you subtract. So first thing I'm going to do is to simplify the whole number. 6 over 12. So we look for a number that can go into 6 and 12, which is what? 6. 6 goes into 12 how many times? Yeah. It goes once. It goes in once, right? And then 6 goes into 12 how many times? Twice. So we have 1 over 2. And then here, we're going to do what? Subtract the exponents. When dividing powers of the same base, we subtract the exponents. So 9 minus 4 becomes what? Okay, let's show the steps. And B 10 minus 8. So the answer will be A 4, B 2 over 2. We don't have to write the 1 because we know there's a coefficient 1 there. And then 9 minus 4 is 5. No, what did I do? 9 minus 4 is 5 here. No? Yeah. And then 10 minus 8 is 2. Is it fine? So the 2 goes at the bottom. Okay, same thing here. Same thing that we did here. What number goes into 5 and 25 without a remainder? 5. 5 goes into 5 how many times? Once. 5 goes into 5 how many times? 5 times. Check on your calculator. 25 divided by 5. That's 5, right? Check on your calculator. And then here, look, I'm going to say 5 minus 6. It's negative 1, meaning I have an x at the bottom. Alright? If I cancel out here, I'll be left with 1x. at the numerator. That's why I have the x there at the bottom. And then here, 10 minus 12 will be negative 2. So meaning I have y squared as a denominator. Does it make sense? Yes. Wonderful, 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 wonderful. Moving along. So this was law 2. When dividing, we subtract the exponents. Now let's look at law 3 and 4. Law 3 and 4 says whenever you see a what? A bracket, you must do what? Multiply. Bracket means what? Multiply. So what will be the answer here? 3 multiplied by 3. It's not 6. How much is 3 multiplied by 3? 9. Yeah, boo. If you write 6, it's wrong. 3 multiplied by 2 is 6. 3 squared is how much? 9. These two, are they the same? No. They are completely different. Ne? If we're squaring the 3, it means 3 times 3. Okay, let's look at this one. What are we going to do there? Distribute the what? The 4, right? Everything inside, we're going to multiply it with 4. What is the exponent for each base? 1, 1. So what will be the answer? 3, 4, y 4, y 4. x4, y4. And then this becomes what? 81. You can press this on a calculator. Only the first one. And then that one stays the same. Is it fine?
Yes, sir.
Alright, okay. Okay, let's do more questions. Okay, guys. Okay, let's do more questions. So I'm gonna pick just a few. I'm gonna do 2. I'm gonna do 11. I'm gonna do this one, and this one. Okay, so let's do that. Then I'm going to do scientific notation, and then that's it. So the first one says 3a9 multiplied by negative b to the power 6 negative 2b3. So bracket means what? Multiply. So what am I multiplying with? Please check. A negative and a negative will be a positive. And then base, this base are the same. Law 1 says when multiplying parts of the same base, we add the exponents. And then here there's an invincible 1. 1 multiplied by 2 is how much? 2. So we have a positive 2. We have a positive 2, and then here I'm going to add the exponents. 6 plus 9 is 6 plus 3 is 9. So negative 1 multiplied by negative 2 is a positive 2, and then here we add the exponents. And then what are we going to do here? Multiply the numbers. 3 multiplied by 2 is 6, and then a 9 and b 9. They are not same base, so I can't add. Yes, so we leave it like that. Yes, sir. So, and then the second question. Negative 2xy 5 4. So what did we say? If we have a negative number inside the bracket, what do? We look at the exponent there. Is it an even number or an odd number? Even. It's an even number, so our answer is going to be a positive. So, but I have to keep it inside the bracket because I have a negative outside. So I know my answer here will be a positive answer. And then I'm going to distribute the power of 4. So what is 2 to the 4? 2 to the power of 4? 16. Ne?
Yes.
So 16. A positive 16 because of the even number. And then x4, y 20 because I multiply 5 and 4. Here it's 1. 1 multiplied by 4 is 4. 1 multiplied by 4 is 4. And then I have 2 to the power of 4, which gives me 16. That's why I have a 16 there. Then a positive and a negative becomes a negative. So my final answer will be a negative. Because if you said a negative and a negative, you're going to get a positive. But you can't, because this is inside a bracket raised to an even number. So you need to know the difference. Okay, moving along. Number 3. 4(2) over 4(3). Okay, this one is straightforward. When dividing parts of the same base, we subtract the exponents. So 2 minus 3 will be 4, negative 1, which means 1 over 4.
Yes,
if you are not sure, press this on a calculator. It will give you a fraction. Yeah, and always leave your answer as a fraction, no decimals. No decimals. Leave your answer as a fraction all the time. Okay, 2 last questions. Negative 24 x 10 y 16 over negative 12 x 5 y 18. Okay, this is straightforward also. Right?
Yes, sir.
Negative and a negative becomes a positive. So our answer is going to be a positive. 12 goes into 24 how many times? Twice. Is that fine? And then here, what are we going to do? Subtract. What is 10 minus 5? What is 16 minus 18? So 2x to the power of 5 and then y to the raised to the negative 2. And then what does the negative 2 mean? It means we must take it to the bottom. So this becomes that. So meaning we have 2 y's underneath. So this, the one with the negative exponent, becomes a denominator. Is that fine? Okay, let's do one more questions before we go to scientific notation. So 12 A4B negative that, and then over negative 2a cubed b to the power of 4 and everything raised to the power of 4. Now look carefully on your screen. This negative, is it inside the bracket or outside the bracket? It's outside the bracket. So meaning it's not affected by even number and odd numbers. So whatever answer we're going to get here, we're going to multiply it with a negative number. And then on the numerator we have a positive 12 multiplied by a negative 4, which becomes how much? What is 4 times 12? 48. Yes, negative 48. And then what is A4 multiplied by A1? We're going to add the exponents. It becomes a to the power of 5. And then what is B1 and B1? Becomes B squared. Everything. And then here we're going to distribute the 4 inside the bracket. So I have a negative number. What is a to the power of 4? We did it. A to the power of 4 is how much? 16. So I have a 16 there. And then I'm going to distribute. Bracket means what? Multiply. What is 4 multiplied by 3? A12. What is 4 multiplied by 4? A16. Is that fine?
Yes, sir.
And then here, we're going to apply the laws of exponents. So 16 goes into 48 3 times, negative and a negative, it's a positive. And then here we're going to subtract. What is 5 minus 12?
It's negative
7.
7.
And then what is 2 minus 16? It's negative 14.
Negative 14.
So I'm going to be left with negative 7 and b 14. And the negatives mean what? Means these two terms becomes a denominator. So this one becomes a numerator and this 2 goes at the bottom and makes a denominator. So that's your answer there. Okay guys. Now the last part of exponent, you need to be able to write it doesn't matter, no? Notation. So, what is the significance of writing things in scientific notation? You're given a bigger number, you want to write it in a way that it would make sense, or a very, very small number, you want to write it in a way that we can use it. So you need to be able to write when you are given scientific notation. You need to be able to write it in ordinary notation. And then you need to be able, if you are given the ordinary notation, write it as a scientific notation. So you need to be able to go both ways. So let's say you are given 3,6 times 10 to the 4. And the question says, write this as a ordinary notation. Another word for ordinary notation is what? Expanded notation. So what are we going to do here? We're going to move the comma. And then how do we move the comma? This tells us how many times we must move the comma. Are we all clear? So how many times are we going to move the comma? 4 times. So look, I'm going to say 3,6. Then I'm going to move the comma how many times? 4 times. So let's count. We count after one step. 1, 2, 3, 4. Now all these open spaces, I'm going to fill them with what? 0. So meaning this is how much? 36,000. Does it make sense? So this is what you do. Let's try another question. 4,8 times 10 to the 5. So this tells us how many steps we're going to move. So we're going to move the comma how many steps now? 5 times. So I'm going to write 4,8, then we move it 1, 2, 3, 4, 5. Then we fill it with zeros there. So what will be the answer? 480,000. Is it fine? Eh?
Yes, sir.
And then you need to be able to write when you're given an expanded notation in scientific notation. So let's pick a question. Let's say we are given 285,000. Yeah, like that is fine. So this is question 1, question 2, question 3.
Yes,
Né?
sir.
We're going to move. Remember here, our comma is at the last. Here, at the last digit. We move the comma up until the first non-zero number. So we count and then we're going to count how many times we've moved. So 1, 2, 3, 4, 5. So our comma is going to be there at the last non-zero number. So that before the comma there should be one number there. So 2,85 times 10. How many steps did we move? 1, 2, 3, 4, 5. Times 10 to the power of 5. So the exponent has to be a positive because we are dealing with a bigger number. Or you can say when we move to the right, to the left, movement to the left, the exponent is positive. So this tells us we're moving to the left, or it tells us that we are dealing with a larger number. Yeah, let's try another one. 3.7 million. 1, 2, 3. So they say write this as a scientific notation. So we're gonna start from here. Our comma is there. We move it up until 3. So let's count. You count immediately after you move. So 1, 2, 3, 4, 5, 6. So we put our comma there. So this will be 3.7, sorry, times 10. How many times did we move? 1, 2, 3, 4, 5, 6 to the power of 6. So this is a scientific notation. Was it fine?
Yes, sir.
Now let's take a very small number. Say we are given 0.000000278. We're going to move the comma up until the first non-zero number. Is it fine? So the comma is going to be here. The first non-zero number is 2. So let's move it. It's going to be 1, 2, 3, 4, 5, 6. So our answer will be 2.78 multiplied by 10 to the negative 6. Now, if I'm moving to the right, I have a negative exponent because I'm dealing with a small number. Can you see? 0.0000278. It's a smaller number compared to what we're dealing with there. So that's why we have a negative value there, to tell us that we are dealing with a smaller number. Is that fine? Yes. Okay, thank you. I'm done.